2, when the sheriff began his pursuit, Robin Hood was already 7 miles out of Nottingham. If the sheriff traveled at 6 miles per hour while Robin Hood's rate was 2.5 miles per hour, how long did it take the sheriff to catch up? This is much more specific about what happened. Obviously, Robin Hood stole something and the sheriff's after him. But
maybe the sheriff stole something from Robin.
It's possible the sheriff might have stolen something from Robin, and then he doesn't want Robin to tell people about it. Let's go with that story. All right, so he's chasing him to catch him. All right, and honestly, I don't think Robin Hood knows he's chasing him either, because I don't imagine Robin Hood's going to get caught by the sheriff, if I remember the stories right. So anyway, here's Nottingham here. And Robin's already 7 miles out of Nottingham. So this is Robin's starting points. This is where Robin starts. And the sheriff is starting in Nottingham. All right. So if I draw in red, okay, they're distances. Robin Hood is going away from Nottingham at some unknown speed. He goes some unknown distance. The sheriff's going at some speed towards Robin Hood because he's trying to catch him out of Nottingham. And eventually he catches up to him. We're going to assume Robin got away.
Why is it not Gothenburg? Why is it not Gothenburg?
Gothenburg instead of Nottingham? I think in the stories it's Nottingham. The sheriff of Nottingham. Yeah. Going into Sherwood Forest. I mean, based on Robin Hood stories I've already seen. You'd rather be Gothenburg?
Yeah.
You should go back in time and talk to the author and have him change the story a little bit. All right. Anyway, what I'm looking at here, looking at this picture, Robin Hood's distance plus the 7-mile head start equals the sheriff's distance. So d sub r plus 7 equals d sub s. The sheriff obviously goes further than he does because he has to make up for the head start that Robin Hood got going out of town. So we have Robin Hood and sheriff as our categories. Looking for rates, times, and distances, or actually rates and times, not distances. So this is what I want to get out of the picture. So I've already used the 7 miles. Again, anytime I get a distance that goes in the picture, doesn't go in the chart. I'm still saying some of you want to put that 7 in the chart somewhere. Well, it says 7 miles, that's the distance, let's put it over here somewhere. I've already factored the 7 miles into the problem by this equation here. So this is where the 7 miles is important. Here, it's not going to be in this chart. All right? Robin Hood's rate was 2.5 miles per hour. You guys like decimals better than fractions most of the time, so let's go with 2.5 there. And rate is in miles per hour, which means time is in hours and distance is in miles. Again, sometimes it's helpful to establish units of things to establish the answers that we get and what they represent. The sheriff traveled at 6 miles per hour. So the sheriff's rate is 6. Once again, we know both rates. Now here's the time issue, and this is, we'll call this the time corollary here. Theorem, time theorem. Let's go with time theorem. Okay, it hasn't been proven, but it's pretty straightforward. It usually works this way. If one of these problems doesn't mention time whatsoever, at all, does that say anything? The sheriff's time was so much more than Robin's time. Robin's time was so much more than sheriff's time. The round trip took this long. The entire trip took this long. There's not a single mention of time anywhere in the problem. The only slight mention of time is within the unit miles per hour. The hour shows up, but it's not saying how many hours, right? So here's the theorem. If a problem like this never, ever, ever mentions time, the times are equal. Since we don't know the times, we're going to put them both as t. If that is inaccurate, it'll cost you 1 problem for the entire year. I can't remember a single problem that happens in, but it might be one problem out there that I completely forgot about that might not happen in. And it's going to happen on a homework problem because it doesn't happen on the test. So it'll cost you 2 points on one homework assignment if that's a false theorem. But I'm pretty sure that's right. If they don't even mention time whatsoever, times are the same. 2.5t would be Robin's distance. 6t would be the sheriff's distance. And according to our setup here, Robin's distance plus 7 equals sheriff's distance. So 2.5t plus 7, which is just part of the equation, equals 6t. And again, notice the plus 7 shows up. 7 miles, that's where it shows up. It doesn't show up in the chart. So 2.5t plus 7 equals 6t. I move my 2.5t to the right. 7 left on the left-hand side equals 3.5t on the right-hand side. Divide both sides by 3.5. T is equal to 2 hours. The question asks, how long did it take? How long did it take? It's asking me about time. Time is t, so that answers the question. If it asked, how far did the sheriff have to travel to catch up to him, the answer would be 12 miles. How much farther did Robin Hood go after the sheriff started chasing him? 5 miles. Okay, so those are the types of questions they could ask you. Everything with a variable represents something you don't know, so that's something they could ask you. So keep that in mind when you do these problems. Always answer the questions being asked.